So, good morning all of you. I am Prof Kamal Lochan Samal, welcoming all of you to a new session of our lecture video of Basic Electrical and Electronics Engineering. That is, today we will discuss about the series and parallel circuit connections of the electrical circuits. Okay. So, in previous class we will discuss about what will be the Ohm's law, how the resistance will be dependent upon the voltage and current, how the current will be changes or voltage will be changes when the resistance value will be changes. In this session we will discuss about how the resistance value will be changes when the equivalent resistance value you can calculate the equivalent resistance of a series circuit and in a parallel circuit when the resistors are connected in series and when the resistors are connected in parallel. So we can start. These are the two diagrams here. If you see the picture or the board, there will be two diagrams. One is your series circuit, another one is your parallel circuit. One the series circuit, the resistance value will be R1 and R2. Both the resistors are connected in series, and it will be energized by energy source, DC source. We can say E. Okay. Similarly, we will consider about we see the parallel circuit. The two resistors R1 and R2 are both connected in parallel. Also, it will be also energized by energy source DC source, that is we called E. Okay. So first we derive what will be the equivalent resistance. We can calculate or derive the equivalent resistance of the series circuit and the equivalent resistance in a parallel circuit when the resistors are connected in series as well as in parallel. Okay. So let us start this derivation. If you see the series circuit, discuss about the series circuit. In series circuit, both the resistors R1 and R2 are connected in series because it will be connected into end-to-end connection. Okay, so these are the resistance value. If it will be starting point, it will be ending point. It will be starting point, it will be ending point. So when we call the resistors are connected in series, when the resistors are connected in back-to-back point or back-to-back connections, we can call it a series circuit, or we can call it the ending of the first resistors will be connected with the starting of the second resistors. We can in that way you can call it the resistors are connected in series circuit. Okay, so what happens when the resistors are connected in series circuit? What is the behavior of voltage and current in the series circuit? What is the behavior of voltage and current in series circuit? Let us derive the expression of the equivalent resistance. We can also see what is the behavior of resistance or what is the behavior of voltage and current in series or parallel circuit. Okay, so here you can see the circuit will be energized by a single DC source. We can call it will be E, and it will be positive and negative. So the current will be flowing in this direction, and we can say the current will be I. Okay. Here in R1 and R2, both the resistors, the single current will be flowing in the circuit will be called as I. Okay. Here what will be happen? Here some voltage will be drop around R1, and we can say the voltage drop around R1 will be V1, and the voltage drop across R2 will be called as V2. Okay. We can call the voltage drop across R2 will be called V2 and the voltage drop across 1 will be called V1. So when we derive our total, this one is your, we will say this one is your total voltage. If we derive this expression, so V is equal to voltage drop across resistor 1 plus voltage drop across resistor 2. Got it? So when we can derive, so when we put this into IR form, so voltage is equal to nothing but in Ohm's law. V is equal to I into R. Okay. In Ohm's law, voltage is equal to IR. If we write this voltage in the IR form or in the IR form, we can write. So V1 will be nothing but it will be the same current will be flowing. So it will be written as I into R1 plus I into R. Okay. So if we take common, and this one will be total voltage and